Good afternoon, respected Chairperson, T. Mahalakshmi ma'am, and all the participants. Myself, Dr. Sandip S. Pathade, Assistant Professor from Depth of Chemistry, MSG College, Malegaon, Nasik, from Maharashtra. Today, I am going to present my research work entitled Synthesis, Characterization, and Computational Insights on Molecular Structure, Electronic Properties, and the Chemical Reactivity of Pyrazoline Derivative, a combined experimental and computational approach. My work is divided into 4 sections. First is the synthesis part. Second one is the characterization of the synthesized molecule. Third one is the DFT analysis of our synthesized molecule. And last one is the conclusion. This is the synthesis scheme for our pyrazolone derivative molecule. First, we take the mixture of the 4-fluoroacetophenone and 2,4-dichlorobenzaldehyde that is stirred at the room temperature in ethanol solvent by using the NaOH as a base. After completion of reaction, we get formation of the intermediate, that is the alpha-beta unsaturated carbonyl compound, which one reflects with the phenylhydrazine in presence of ethanol by using the NaOH as a base. After completion of reaction, we get formation of our desired product, that is the pyrazolone derivative, which is yellowish in color, having the melting point 118 to the 120 degrees Celsius. Then we carry out the spectral analysis for our molecule by using the various spectral techniques like the FTIR, H1NMR, and HRMS. This is the IR spectrum for our synthesized molecule. This IR peak shows that the peak at the 3068 centimeter inverse clearly indicates the presence of the CS staging frequency, while the peak at the 1592 centimeter inverse clearly indicates the presence of the carbon double bond nitrogen frequency, while the frequency at the 1494 centimeter inverse that indicates the presence of the aromatic carbon-carbon double bond staging frequency, while other peak is also well resemblance with the structure of the molecule. This is the H1NMR spectrum of our molecule. The peak in the de-shielded region, that is ranging from the 6.8 delta to the 7.7 delta, that clearly indicates the presence of the aromatic protons, while the peak in the shielded region, that is indicates the proton present on the sp3 hybridized carbon atoms. This is the CMR spectrum of our molecule. In the CMR spectrum of our molecule, the peak in the de-shielded region, that is beyond the 100 delta value, that indicates the presence of the aromatic carbon, while the peak at the 41 and 61 delta value, that clearly indicates the presence of the aliphatic carbon, that is the sp3 hybridized carbon. This is the HRMS spectrum of our synthesized molecule. Our molecule having the molecular formula C1, that is C21H15N2Cl2F, that having the calculated mass 385.06, that is in the HRMS spectrum. We observe the peak at the 385.06. Therefore, this resemblance clearly indicates the formation of our desired product. Then we carry out the computational study of our molecule by using the density functional theory. Nowadays, density functional theory is very crucial to investigate the molecular structure, various spectral properties, various electronic properties, and various thermochemical properties of the organic molecules. First, we optimize the geometrical parameters by using the DFT method with the B3 level, and by using the 6311 plus GDP basis set. We first optimize the geometry of our molecule. This is the optimized geometrical structure of our synthesized molecule. Then we investigate the bond length and bond angles in the molecule. The result shows that the carbon-carbon single bond is well resemblance with their normal values at 1.54 angstrom units, while the carbon-carbon double bond value in the aromatic compound, that is well matches with their normal values, that is 1.40 angstrom units, while the carbon-chlorine bond having the highest bond length, that is well attributed due to the highest or larger atomic size of the chlorine atom. This is the bond angles of our synthesized molecule. This bond angles is also well matches with the normal values, that the sp3 hybridized carbon having the normal bond angle, that is 109.5 degree, while the sp2 carbon atom, sp2 hybridized carbon atom having the bond angle, that is the near about 120 degree. Then we also investigate the molecular atomic charges of our molecule for our synthesized molecule. Nowadays, molecular atomic charges are very crucial to determine the reactivity of the molecule. Therefore, we investigate the molecular atomic charges by using the two different basis set, that is the 631 GDP basis set, and another one is the higher basis set, that is the 6311 plus GDP basis set. And this is the result of the molecular atomic charges. This result shows that this nitrogen atom is the electronegative in nature. At 631 GDP basis set, that shows the negative molecular atomic charge, while at the 6311 plus GDP basis set, that shows the positive, that is the positive molecular atomic charge. Therefore, it is clearly shown from this result that the 6311 plus GDP basis set overestimate the charges, while 631 GDP basis set that gives the normal atomic charge. This is the molecular charge distribution of our title molecule that is calculated by using the B3 leaf level at the 631 GDP level, while this is the graphical representation of our molecular atomic charges, which is clearly indicates that the higher basis set overestimate the charges, while the lower basis set predict the reliable molecular atomic charges for the synthesized compound. Then we also investigate the various electronic parameters of our synthesized pyrazoline derivative. We investigate the HOMO-LUMO orbitals of our molecule. These HOMO-LUMO are the very crucial frontier molecular orbital. HOMO stands for the highest occupied molecular orbital, which is electron donor in nature, while the LUMO stands for the lowest unoccupied molecular orbital, which is the electron acceptor in nature. This is the very crucial orbital which decides the reactivity of the molecule, and that is also affinited with the electron affinity and the ionization potential of the compound, while the difference in the energy gap between the HOMO and LUMO predicts the kinetic stability of the molecule. This is the energy gap of our synthesized molecule, that is a 3.74 electron volts. Therefore, that shows our compound having the lower energy gap. Therefore, our compound is soft molecule, so that is more polarizable and higher and having the highest chemical reactivity with the low kinetic stability. Then we also investigate the various thermodynamic properties like the total thermal energy, total molar capacity at constant volume, total entropy, and 0-point vibrational energy and rotational constant by using the same level of the theory. These thermodynamic parameters are quite useful to assess the various thermodynamic stability of the molecules. Also, these parameters also useful to the thermochemical region, as they can be used to estimate the direction of the chemical reactions. Then we also investigate the molecular electrostatic potential surface analysis, that is the MEP analysis. This MEP illustrates the charge distribution of the molecule three-dimensionally. The charge distribution within the molecule widely been used as a chemical reactivity index to study the interaction between the various molecules. Now, this MEP shows the different values of the electrostatic potential, and that is represented by the distinct colors. The red color in the MEP map shows the negative electrostatic potential. That means region having the highest electron density, and that region is prone for the electrophilic attack. While the blue region in the MEP map indicates the positive electrostatic potential, that is the region of the lowest electron density, and that region is responsible for the nucleophilic reactivity. While the yellow region or yellow color in the MEP map indicates the slight electron rich region, while the green color denotes the zero electronic potential. Therefore, in accordance to this color grade, it is clearly indicates that the red color having the highest electron density, while the blue color having the lowest electron density. This is the plotted MEP map of our synthesized pyrazoline derivative. This map clearly shows that the orange color or yellowish color that is spread over the aromatic ring that is directly attached to the nitrogen atom. Therefore, this region is susceptible for the electrophilic attack, while the blue region that is spread over the carbon double bond nitrogen. Therefore, this region is suitable for the nucleophilic attack. Then we also computed the UV spectrum by using the DFT method. We computed UV spectrum in the gas phase as well as DMSO phase. In the gas phase, we observed this UV spectrum that having the lambda max value 67.05 nanometer, while in the DMSO phase, this is the UV spectrum that having the lambda max at 375.61 nanometer. Therefore, it is observed that in the DMSO there is the increase in the lambda max value. Therefore, from gas phase to the DMSO, there is observed the bathochromic shift in the molecule. While we also take the experimental UV spectrum for our synthesized molecule. This is the experimental UV spectrum of our molecule that having the lambda max value that is 362.06 nanometer, which is well matches with the computed value at the 370.5 61 nanometer. Then we also carry out the vibrational analysis for our molecule. The experimental FTIR spectrum of the compound has been recorded in the solid phase, while the computed vibrational spectra is computed in the gas phase at the B3 leaf level using the 6311 plus GDP basis set. In our molecule, there is a total 41 atoms. Therefore, total fundamental modes of vibration is the 117, according with the formula that is 3n minus 6. Due to the non-planar structure of our molecule. This is the experimental FTIR spectrum, while this is the computed FTIR spectrum for our synthesized pyrazoline derivative. Then we carry out the selected experimental and computed vibrational assignments in the experimental and computed frequency. In the experimental FTIR, we observe the peak at the 3068 centimeter inverse, that is due to the CS stretching frequency, while in the computed frequency, this frequency is well matches at the 3079 centimeter inverse. While in the experimental FTIR, we observe the peak at the 2924 centimeter inverse, that is due to the C3H stretching frequency, and that is well matches with the theoretically peak observed at the 2937 centimeter inverse. Also, in the experimental peak, we observe the peak at the 1592 centimeter inverse, that is due to the carbon double bond nitrogen stretching frequency, and this peak is well matches by the computed frequency at the 1576 centimeter inverse, while other frequency also well matches with the computed and experimental peaks. Conclusion. The protocol for the synthesis of the pyrazoline derivatives reported here is the efficient and that affords the product with the desirable yields. Also, the workup method for the isolation of the product is very easier, and very only reclassification method is required for the purification. There is no need of the column purification required for the synthesized molecule. Then all spectra are ideally matches to the structure of the synthesized compound. Geometry optimization, the geometry optimization clearly predicts that our synthesized molecule having the non-planar geometry with the C1 point group symmetry. The molecular atomic charges prediction structurally matches at the lower basis set, that is 631G, while at the higher basis set, that is the 6311 plus GDP basis set, this basis set overestimate the atomic charges. While the MEP map clearly indicate that the negative electrostatic potential is spread over the electronegative atoms, while the positive electrostatic potential is spread or found on the hydrogen atom. Also, we computed the UV spectrum and IR spectrum. The computed UV visible wavelength and the vibrational frequencies at the B3 level with the 6311 plus GDP basis set are in good agreement with the experimental values. Therefore, all this result clearly shows that the DFT computations provide the firm explanation for the reactivity of the synthesized compound. These are some references that is utilized for this work. Thank you.
First of all, I would like to thank the delegates and the organizing committee of ICCMEPR 2024 for giving me such an opportunity. And also, I'm really grateful to Dr. Indranil Maiti to give me this opportunity to present on his behalf. So the paper is titled as Computation of Key Analog Circuit Parameters Employing Different Topological Configuration of Current Mirror Circuits. This is a comprehensive analysis of gain, noise, and power consumption. And our paper ID is 56. So our paper focuses on systematic designing and simulation of three different configurations of cascade current mirrors, each with 5-volt DC input voltage, and also to obtain competent values of different parameters by analyzing the gain, the AC gain, the noise power spectral density or the noise PSD, and power consumption. Now, all these was orchestrated in the ADEL environment of a software known as Cadence Virtuoso, which offers a versatile platform for every stage of the circuit design process. In addition to this, we also employed the generic process design kit or the GPDK 90 library or the 90 nanometer technology library. The simulation outputs were displayed through different characteristic outputs. Now let us see what is a current mirror. Current mirrors are typically circuits whose output current is exactly the mirror image of the input current, having a constant magnitude irrespective of the load at the current. Besides replicating, these circuits can also amplify or attenuate the reference current. On the other hand, cascade current mirrors are just a simple modification over the simple current mirror circuits. They aim at maximizing performance metrics. Since these aforementioned parameter values and the circuits readily improve the performance of any circuit, therefore the aim of the paper was to showcase that improved circuit could be designed in the future with the values obtained. The process was initiated by configuring the PMOS and NMOS transistors in the CMOS technology by connecting them with narrow wires and associating the labels, wire names, and necessary input and output pins. This slide shows the AC schematic diagrams of the three configurations we proposed in our study. The first one represents a differential pair with active current mirror having 5-volt AC input voltage. The second figure also showcases a differential pair, but this time having 1.5 volt as the input voltage. The last figure represents a unity gain buffer circuit with the lowest input voltage, that is 1 microvolt. Now, the main role of a unity gain buffer circuit is to increase or decrease the impedance in a circuit as and when deemed necessary, and therefore this was taken into consideration for a study. These slides show the different simulated results for the 3 different circuits, and the AC gain values were obtained as 8.76, 14.98, and 0.37 decibels, respectively, for the 3 circuits in order. We can see that the second configuration attained the highest AC gain, whereas the third configuration gave the lowest one. The possible explanation that could arise is that the first 2 configurations having 2 input pins, they enhance even the smallest differences most significantly, thereby increasing the transconductance and leading to higher AC gain values. But for the unity gain buffer circuit with only 1 input pin, this is not possible in this case because the reduced input voltage also reduced the transconductance but increased the output resistance, and therefore such low gain was observed. The next slide shows the results from noise PSD calculations. The noise power spectral density or PSD values were obtained as 0.97, 24.58, and 31.70 micro volt square per hertz, respectively, again for the 3 circuits in order. This time, the third circuit gave the highest noise PSD value, which was undesirable, followed by the second and the first configurations. The unity gain buffer circuit gave us such values because I'm sorry, it substantially increased the flicker noise, which reduced the transconductance this time. But this was not the case for the first 2 configurations because they provided better common mode rejection ratio, and thus an increased transconductance was obtained. Therefore, their noise PSD values, though not desirable to certain point, but comparatively well less than what obtained for the third circuit. Lastly, the slide shows the result analysis from the power consumption perspective. As we can see that the first 2 configurations gave ideal power consumption values, which was 509.6 picowatts, and it was a flow order. And the last configuration consumed the highest power of 36,280 picowatts. The reason for this was that for unity gain buffer circuit, the reduced voltage led the circuit to draw maximum current, therefore maximum power was consumed. But this was not the case for the first 2 configurations because there they had 2 input pins and the total current in the circuit was the sum of the circuits individually through the 2 transistors. Therefore, even if the voltage was reduced, the circuit was able to maintain a balanced operation and they rejected any kind of common mode variations. Thus, the power consumed here was comparatively less than what was consumed in the third case. An overview would tell us that the circuits with highest AC gain, lowest noise PSD, and lowest power consumption values are the most efficient ones to be designed in the future, and this is supported by the outputs that have been received, expressed in this slide. A comprehensive analysis showed or gave insights into the functionalities and capabilities of cascade current mirror circuits. To sum up, we can say that the second configuration attained the highest AC gain of 14.98 decibels. The first and second circuit configurations demonstrated lowest and identical power consumption of 509.6 picowatts. And furthermore, the first configuration also exhibited lowest noise PSD value of 0.97 microvolt square per hertz, indicating minimal distortion to others. With this obtained competent and optimized values, we can definitely build or design efficient and improved circuits in the future, which would surely have an emerging effect on the current semiconductor industry and the VLSI design domain in the future. So, with this, I would like to end my presentation today. And thank you everyone for your esteemed presence.
Okay. So good afternoon all. Myself Digambar Yevale. I am working as a senior scientific manager in one of the leading CRO, Origin Life Science Limited at Hyderabad. Here I have a team of 26 scientists and here working in drug discovery department. So I'm pursuing my PhD from Kadi University, Gandhinagar. So, title of my presentation is PI3K delta and mTOR dual inhibitor design, synthesis, and anti-cancer evolution of three substituted aminomethylquinoline analog. So, I have abstract of this. Next slide. So here, abstract is the phosphate dinylosity 3K, PI3K, and mammal target of rapamycin. These are the two recently identified potential targets for cancer. In our work, we have synthesized a series of quinoline analogues and evaluated against the PI3K delta and mTOR inhibitor. In preliminary biological activity analysis, we could able to see the compound 5H and compound 5E show the potential anti-cancer activity. And so we have tested this both the compound 5H and 5E in the anti-tumor Ramos cell on the Ramos cell line, and we observe the compound showing IC50 value 0.26 micromolar for the PI3K delta and 0.34 micromolar for mTOR. Along with that, the IC50 value of 0.042 and 0.056 micromolar for PI3K delta, as well as 0.053 and 0.073 micromole for mTOR respectively. In the introduction, what is the means of PI3K and mTOR? PI3K and mTOR mammalian target of rapamycin, PI3K AKT mTOR PAM pathway has drawn significant pharmacological investment in the research for inhibitor treat the human cancer. So this PI3K delta have different form, that is PI3K1, PI3K2 and PI3K3. So PI3K1 is a well studied form of this PI3K inhibitor, but there is huge scope to study this PI3K2 and 3. There is no much research done on these two isoforms. Also, there are subunit of this PI3K delta, that is alpha, beta, and gamma and delta. For our this paperwork, I have done the selective synthesis of selective compound for the delta isoform. So, what is the actually exact role of PI3K delta in our body? So, it is playing important role inside the cell, and that is the cell proliferation, development of the cell, and cell survival. So, any mutation in this PI3K delta during this process lead into the cancer, that is uh, lymphomatic cancer. And mTOR is the downstream signaling effect in the PI3K delta AKT mTOR cascade. This kinase belong to the phosphatidylinosytol 3 kinase family, and this also involve in the downstream effect of this mTOR cascade. There are these 6 different compound I have mentioned, which are clinically available in the market. This 5 and 6 still under study, but first 4 are available in the market for this lymphocyte cancer. What is the rationale behind our designing of these targets? So here we have used compound 1, C, and D as a reference standard to design our compound D and E. On the basis of that, we have tried to maintain the central core quinoline analog, quinoline ring, and that is the important for ATP binding pocket. And also we have replaced this CF3 pyrazole CF3 of intermediate compound A by using a triazole bioars historically, and this N-ethyl heterocyclic atom we have replaced with this anilinic and benzylic substituted different moieties. And we have added this methoxy group in our design compound D and E to maintain the lipophilic content in the surface. So this is the synthetic scheme for the synthesis of this total 14 analog. First step is the acetylation by using this acetic anhydride and acetic acid at 100 degrees Celsius. Second step is Willsmere formylation followed by a cyclization using a POCl3 and DMF. And in third step, we have attached this triazole ring to the chloro by using sodium hydride and DMF at 80 degrees Celsius. And finally, we use this intermediate 4 as a common scaffold to use the coupling with the different amine, aliphatic, aromatic, and benzylic amines by using reductive amination condition. There we have used this sodium cyanoboride, methanol, and acetic acid as a solvent for the reaction. In all the substrate, we got almost above 80% conversion for the final analog, and I have synthesized almost each compound 100 mg and tested for the biological evaluation, which I have already mentioned, and few slides I'm going to explain in detail. So this is the cytotoxic activity we have run against the Ramos cell. Ramos cell is isolated from the beta ramphoside patient, a 3-year child from America. And we tested all these 14 analog by using this cell line. And the results is monitored in the micromoles. So here we observe, and also we have used this dactolisib as a reference standard, which is marketed drug. It shows the 0.76 micromole activity. So out of these 14 compounds, almost we observe 2 compounds showing good activity. That is the compound 5E, this 0.34 micromolar, and highest potent compound is this compound 5H, 0.26 micromolar. So we decided to take this both the compounds for the further study. So again, enzymatic activity of these 2 compounds we have run against PI3K isoforms and mTORs, and we observe here also we have used same reference standard compound, that is the dextolisib. And we observe our both the compounds 5E and 5OH showed good potency for the PI3K delta as compared to the reference standard here. The reference standard dextolip is showing activity 0.069 micromole for PI3K delta, and our compound 5H is showing 0.042 nanomolar, which is quite good as compared to the reference standard. And compound E is showing moderate activity, that is 0.056 micromolar. So by this isoform study, we also concluded that our synthesized target are PI3K delta selective. So overall structure activity relationship I have mentioned on this slide, because we have synthesized different analog aliphatic, benzylic, and anilinic compounds. So this main core, as I mentioned, this lipophilic contact is maintained for this PI3K delta, MET 900, and isoleucine 910 residue, as well as for this mTOR. And this ring is useful to maintain the leucine 2185 and lysine 2187 interaction. This methoxy group is important because it is showing hydrogen bond with valine 828 and PI3K delta. And then we have installed newly to get the novelty of this triazole ring, which is showing lipophilic interaction with the isoleucine 825 residue of the PI3K delta and hydrogen band and lipophilic contact with the GLN 216 and serine 2165 of mTOR. This benzylic NH proton is showing a hydrogen bond with aspartic 911 of the pi3k delta. So these are we have done the different variation, alkyl substituent and benzylic substituent and anilinic substituent. Among these, the substituted benzylinic substitute, 3,4 substituted benzylinic ring with electron donating and withdrawing group showed most potent compound that I mentioned already, compound 5H and 5E. Further, we have evaluated this 5H highly potent compound for the Western blot analysis. And in the Western blot analysis, we can clearly see that the various concentration resulted into the dose difference decrease in the level of PAM signaling of this PRPS6, serine 239 to 236, as well as phosphorylated AKT threonine 308 and phosphorylated AKT serine 478. As compared to the standard, we can clearly see the decrease in the level of PAM signaling. It is clearly showing that our compound is PI3K and mTOR signaling effect. For the further confirmation, we have done the apoptosis analysis of our compound, and here we can see that the apoptosis activity of 5 compound and is 0.26, and further investigated by using this Annexin V FITC assay, and in this assay we could able to clearly show. In this assay, we can see what is the living cell present after treating this compound with this assay. What is the early stage apoptosis and late stage apoptosis? How many necrotic cells are present? Based on this result, we can easily conclude the results of our compound. So, for my compound 5H, this overall apoptosis was 13.6 times higher than the control. And this is the control, and this is the our 5H compound. So it is clearly showing that this compound is having good activity against this PI3K delta and mTOR. So this is the main part of my presentation. These are the different references I have utilized to write this paper, and this paper is recently published in the Bioorganic Chemistry, having impact factor 5.4 previously when I saw. So thank you for listening patiently, and thank you for the organizing committee for giving me opportunity to present my work here.
So good afternoon everybody present here. First of all, I want to thank the organizer to giving me the opportunity to present some of my research work here in the International Conference on Composite Materials for Environmental Protection and Remediations, ICCMEPR 2024. So all we know that even in the nowadays, we are using mostly the carbon-based fossil fuels for energy purpose. And this here we have the limited resources. And the energy demand is increasing day by day. So this use of this carbon-based fossil fuels also increasing the greenhouse emissions that directly affecting the environment as well as the human life. So the electrochemical energy conversions and storage system is required for the green and clean energy. So for this purpose, we need the development of sustainable, cost-effective, renewable and usable energy. And nowadays, in the last 1 or 2 decades, people are using the water splitting reactions to generate the hydrogen energy. So this water splitting reactions involves 2 half-cell reactions, one the catalytic hydrogen evolution reactions and anodic oxygen evolution reactions. So here we are going to I am going to discuss some of my complexes and materials that has been used for the oxygen evolution reaction. So this oxygen evolution reactions is generally require the high over potential. It has the sluggish kinetics, and this is the multi-step reactions. That is the 4-electron multi-step reactions. You can see the OER reactions mechanism here. So both in the acidic and alkaline conditions, this require the 4-electron systems, and this is the this multi-step reactions. So this require this thermodynamic potentials to 1.3 to 3 volts, and this is also the over potential. The extra potential is required for this to achieve the OER reactions. And to do these reactions, we need this electrocatalysts, so that we can reduce these over potentials and kinetic barriers. That it will be very important. The catalyst should be the stable, cheap, and easily synthesized. So people are using generally this noble metal-based electrocatalyst for this purpose. That we all know these are the metals have been used as a noble metal for the catalyst purpose. But this is the very high cost and the low abundance, so it limits practical implications of this catalyst. So nowadays people are starting designing this electrocatalyst using the earth abundant metal, that is the nickel, cobalt, and irons. And there are many work has been going in this directions nowadays. Nickel based catalyst, this cobalt based catalyst, and this iron. They have the many review articles and many work is going in this area. So what is our objective? Our objective here to synthesize the metal complexes, new metal complexes that should be novel, or the metal organic frameworks using earth abundant metal. So it should be the cost effective methods, and use them as electrocatalyst for the OER and HER reactions. The second things, even you can derive the materials from these complexes or metal organic frameworks as oxides, sulfides, or phosphides, and use them as a electrocatalyst purpose. And sometimes even support this, giving the support of these materials as a graphene oxide or CNT, and again then this material has been used as a electrocatalyst for these reactions. So here, because due to the time limitations, we are going to present here some of the 1 or 2 projects here. So project number 1. So this is a very simple reactions. We have done this, taken the cobalt acetate, tetrahydrate, and this 2-dimethyl 3,5-dimethyl pyridine, that is also called the lutidines, and dissolved in the acetonitrile, and stir at the room temperature, but only for the 3 hours. And this is given this complex, this the cobalt acetate, cobalt compounds, cobalt complexes that have the 2 acetate moiety and 2,3,5-lutidine moiety, and these 2 water molecules. So this is the novel compounds, and this is first time reported by this is the single crystal X-ray data, and we have characterized with the single crystal X-ray data, and we have seen that the supramolecular view of this compounding, the surrounding around these molecules, and these molecules has been in the crystal lattice. It is connected with the hydrogen intermolecular hydrogen bonding with OH hydrogen bondings with surrounding the 4 molecules. So this is the hydrogen bond parameters for this intermolecular hydrogen bonding, and this shows that this is the strong hydrogen bonding between the intermolecular hydrogen bonding, OH hydrogen bonding within these molecules. So then we have see that this supramolecular view of these complexes in the C3 axis. So it is growing like this, the molecules. This is the same of these molecules. This is growing the C directions of these molecules. So we have seen that this is the space field model for these compounds. So this has been see the hexagonal holes within these molecules. That this compound is the as a molecular complex is very porous in nature because it has a porous structure within the molecules. The surface analysis also done with the crystal lattice of these molecules along this C axis. So some of the computational study as so then we have done the GFT calculation to find out the energy and see that this intermolecular interactions of between the molecules with the MEFP diagrams, and this RG plots indicate that the non-covalent reactions in the founding in the solid state structures is the similar with this very good agreement with this computational study. Then we have gone for this electrocatalytic activity of these complexes. So complex 1, we have done the electrocatalysis for the OER reactions and compared with this benchmark catalyst. People are using this iridium oxide as a benchmark catalyst. We have compared with the upper data with the literature value. So we have seen that in our my complex, in the very simple complexes, but this activity is very much high compared to this iridium oxide benchmark catalyst of iridium oxide. As we can compare with this LSV polarization curve and other TOEFL plots, this over potential has been seen that this TOF of this our complexes is almost 2.5 times higher than the iridium oxides. So what this complex is very much this useful. So just we have seen summarizing this project 1 here. The complex we have synthesized the complex 1 and it has been characterized by single crystal structure data. So this activity of this catalyst is better than that the state of art iridium oxide catalyst. This may be due to this 3D porous structure of this rapid transport of ions. That is because we have shown that the porous structures, they have the different pores, the hexagonal pores inside the molecules. So this is the transport of ions, increasing the transport of the ions. High accessibility of the cobalt sites, because this flexible ligands has been used, that is 3,5-lutein at a Lewis wave, and there is higher electron density, these were Lewis wave structures, and the coordination flexibility, because the CTS commodity we have the coordination flexibility around the metal center. So this may be the reason for this higher activity of these compounds. Further, the post-catalytic activity of XPS, FTIR, ADX analysis also confirm the retention of the electrocatalyst in terms of bulk compositions, formations of this cobalt 2+ and cobalt hydroxides, cobalt COH in the HER during the HER reactions. This MEP map analysis depicted the electron-rich centers in the complex 1, which also found well in agreement with the solid structures. This work has been published last year in the RSC advanced papers here. The second project here, I'm going to tell you that we have just designed the simple ligands by reacting with 2-propanedienaldehyde with this 2-penylthiophenols, and this has been reacted with this nickel chlorides with presence of ammonium thiocyanate in methanols at 80 degrees centigrade. We got this compound nickel complexes with two molecules of ligand and 2 isocyanate groups. And this also characterized by this single crystal structure data, and this compound having the CH pi interactions, not the CH OA interactions. This is CH pi interactions within the molecules. So we thought that these compounds, we generate the materials to use the electrocatalyst. So first, before annealing these compounds, we have seen that TJ analysis. So we have seen that the end products, getting the end product, that end product is nickel sulfides after decomposing these compounds. So we taken these compounds, the nickel complexes, and this we have been annealing at the 400 degrees centigrade, that giving the nickel sulfides. And this nickel sulfide has been sonicated with this functionalized multi-walled carbon nanotubes, that's giving the nickel sulfide CNT. Another way we can also do that is same getting this nickel sulfide CNT in another way. Directly we have just first sonicated with this complex with the multi-walled CNT, and then this nickel complex CNT in 400 degrees centigrade is the nickel sulfide CNT. This is characterized by different spectroscopy data. This powder study of this nickel sulfide and nickel complexes, and this nickel sulfide will be compared with the JCPDS value, and this is giving it indicating this formation of nickel sulfides. This is the carbon nanotubes, multiple carbon nanotubes, nickel complexes, and nickel complex CNT. So this nickel complex CNT also this carbon nanotubes fixed here. So and then FTIR, again the nickel sulfide and nickel complexes, Then there is nickel complex with nickel complex CNT, multiple CNT. This and then Raman spectra here. Raman spectra also indicating the formation of nickel complex CNT with a nickel sulfide because of nickel multiple CNT. So this data supports our hypothesis formation of this nickel sulfide to nickel sulfide CNT formations here. This is XPS analysis of all four materials. The comparative tables we have made for this all the data from the XPS FTI for all the four compounds that we have prepared and compared with our starting materials. The FE measure of these nickel complexes, then you have nickel sulfide CNT, and this is this nickel complex CNT, and then nickel just decomposed material nickel complex nickel sulfide CNT. So we have done the electrocatalytic activity of these all four materials and compared with again this iridium oxides. So we have initially we have seen that the activity of nickel complexes is very less. Once we could decompose with the nickel sulfides, the activity is slightly increasing. That is even the less than the iridium oxide here. But once we have given the support for this carbon nanotubes, the activity enhanced drastically for both the case nickel complex CNT and the nickel sulfide CNT. So this analysis has been done again for the we have drawn the all the data from this compare this Tafel plot and then just negative slope plot for the nickel thiocyanide complexes, nickel sulfide, nickel complex CNT, and nickel sulfide with the CNT materials. The TOF value indicate this nickel sulfide CNT has the higher activity compared to the nickel complex CNT, then nickel sulfide, then nickel complexes. The stability of this compound also done by the before and after the stability, and this is the almost this catalyst is stable even the reaction during the reaction period. So we have just concluded this here. The synthesize and strictly characterize these sulfur-rich nickel complexes to design the new and efficient OER electrocatalyst, and this sulfur-rich nickel complexes was used as a single source precursor to synthesize the nickel sulfide directly by simple annealing methods. And the nickel complex and derived nickel sulfide coupled with a functional multi-walled carbon nanotubes to enhance the conductivity and surface area of this reaction. The performance of catalyst was compared with state-of-art iridium oxide catalyst and found as follows: the nickel sulfide CNT, then nickel complex CNT, and then iridium oxides, then the nickel sulfide and the nickel complexes. This is the first time reported the nickel complexes derived by nickel sulfide CNT showed the enhanced OER activity in terms of low over potentials, the 330 microvolt to reach the 10 microamperes per centimeter inverse. This work under the review for this ACS applied nanomaterials. So we want to acknowledge the Deshbandhu College, University of Delhi, to give the infrastructures, IIT Delhi for this characterization purpose and doing the electrocatalysis for our collaborations. This is the funding for this SCRV. These two students is working in this project. Ms. Deepka and Ms. Priya, and this collaborator, Professor Parveen Gule from IIT Delhi, to do the electrocatalysis for this reaction. So now, just you can see that we always think about this environment to stay the safe, to enjoy the life. And thank you.
You can go ahead.
Okay, so first of all, good afternoon, one and all being present here, and thank you all to the organizing committee of this conference to provide me this opportunity so that I could present my work at this platform. So the topic of my presentation is a novel approach to synthesize multifunctional nanopigment, and just a second, sir. Yeah. So nanopigments, we can say that these are the class of the nanocomposite which generally have advantages of both organic dyes and inorganic pigment and can be used as colourant to generally increase the attraction of the given product, because whenever we see a bright colored product, obviously we attract toward that product, and it not only increases the G.
Ma'am, your slides are not moving. You have to just click on the slide. You're still, yeah.
Yeah, now it is moving. Fine.
Okay. So this is second slide, no? Second slide is showing, yeah.
Nanopigments.
Yeah. Okay. So, nanopigment stage, these are of generally of two types: metal oxide nanopigments and clay-based nanopigments. And today we are going to discuss about the clay-based nanopigments. So, if I talk about the clay-based nanopigments, that these are the hybrid metal which generally formed by the combination of a layered silicate minerals, or we can say clay minerals, and the organic dyes. And these clay-based nanopigments are used for different type of the applications like paint and concrete industries, optoelectronics, printing inks, and in my work, I am using these clay-based nanopigments in the polymermatics to increase the color fastness, mechanical strength, thermal stability. As I discussed in the previous slide, that these clay-based nanopigments not only increase the attraction of the given product, but also physicochemical properties. And in the physicochemical properties, we can include thermal stability, mechanical properties like tensile strength, hardness, young modulus, all these. Because we are talking about the clay-based nanopigments, so let's discuss about the clay minerals. There are two basic units which are found in the clay minerals. One is the tetrahedral layer, and other one is the octahedral layer. And based on this arrangement of these octahedral and tetrahedral layer, they are generally categorized into two different units: 1:1 and 2:1. Group of the clay minerals. In 1:1, there will be one octahedral and one tetrahedral layer is present, and these are the examples like colonite and halloysite. And here this is known as the interlayer space between these two units. And in the interlayer space, generally water molecules are present here. And in case of the 2:1 group of the clay minerals, one octahedral layer.
Ma'am, you are still on third slide.
Move on your slides.
Just a second.
Scroll the slides. Okay.
Now, ma'am.
Yeah,
You're there on the fourth slide.
Okay. Thank you. So, in case of 2:1 group of the clay minerals, one octahedral layer is sandwiched between the two tetrahedral layers. You can see, and these are the examples of the 2:1 group of clay minerals like pyrophyllite and smectite, vermiculite, elite. And because of in case of the smectite group of clay minerals, the interlayer space is found to be maximum here. And in this interlayer space, some inorganic ions are also present like sodium ions, potassium ions, calcium 2 positive, and water molecule, all these. So generally, these pristine clay minerals generally have negatively charged due to the isomorphic substitution of the silicon, which is present in the tetrahedral layer with the aluminium. And and because of the presence of the water molecule in the interlayer space, the clay minerals, they are hydrophilic in nature. So I am using these clay minerals as an adsorbent for removing of the dyes, and also as inorganic fillers in the polymer matrix, because the polymers, they are hydrophobic in nature and clay is the hydrophilic in nature. So this is very necessary to modify the surface of the clay minerals. So here in my work, I am using the cetyl pyridinium chloride, which is a cationic surfactant, right? So when this cationic surfactant interact with the clay minerals, then there are different ways of the interaction. First one, that is through the ion exchange method. These cationic surfactant could be present in form of the monolayer by replacing the inorganic ions from the interlayer space, and this could also be present in form of the bilayer. And as the surface of the clay mineral, this is the negatively charged, and surfactant is the cationic in nature, so there is electrostatic interaction, and this could be present in form of the monolayer as well as in form of the bilayer, depending on the concentration of the surfactant. So after the interaction, what we found that in case of the pristine monomonolite, the basal spacing, which is confirmed from the XRD pattern, that is 14.45, and in case of the organoclay, it is increased from 14.45 to 17.50, which again indicate that the cationic surfactant, which is CPC, cetyl pyridinium chloride, is present in between the layer of the clay minerals. And when we measure the surface charge, then the surface charge of the pristine empty, that is minus 17.6, which is due to the presence of the negative isomorphic substitution. And on interaction with cationic surfactant, it changed to plus 29.30. So again, it again confirmed that instead of interlayer presence of the CPC in the interlayer, there is surface interaction, and this is further confirmed from the FTI spectra. The peak here around 2954 and 2833 centi-inverse, which is due to the presence of the asymmetric and symmetric stretching of the methyl group, again confirm the presence of the cationic surfactant on the surface of the clay minerals. Now, generally, what happens that in most of the literature, what we found that what are the people's doing that by using a suitable adsorbent, only dyes are removed from the water bodies, and that's it. But they are not using that dye adsorbent. So, generally, what happened here that what we can call that dye adsorbent, this is the second generation based product. So here in our work, we are using this second generation based product as a nanopigment in the polymer matrix to form the polymer film. Here I am using two type of the dyes. One is the cationic dye, that is the crystal violet dye, and other one is the indigo carmine dye, that is the inorganic anionic dye. So crystal violet dye cationic in nature, and here the triphenyl methane is the chlorophyllic group, which is mainly responsible for the violet color of this dye, and this dye is generally used in the textile industry on a large scale, but it is also recalcitrant and remain persist in the environment due to its non-biodegradable nature. And when a human being comes, when it is found in the when it goes into the water bodies, then it generally promote the tumor growth in some species of the fish. And if I discuss about the indigo carmine dye, this is anionic in nature, one of the oldest dye that is used in the textile industry. And when a human being comes in contact with this dye for a long duration, then some various health effect can be occur, like skin and eye irritation, vomiting, diarrhea to human beings. So this is very necessary to remove these dye from the water bodies. So for removing the dyes, we by employing the batch method, generally these dyes can be removed, and batch method are employed as a function of pH, contact time, and the initial concentration. And this is the formula which is used to calculate the amount of dye adsorbed by the clay and the organoclay. So these are the batch result of the batch extraction studies as well as XRD. In case of the pristine MT, the adsorption of CV dye was found to be 407 mg per gram, and vessel spacing was 17.0, which is generally indicate that the CV dye is present in the interlayer space as well as on the surface of the pristine MT, because surface charge generally reduced. But in case of the MTIC, means on the adsorption of the indigo carmine, the dye uptake was found only 14.6, because clay is negatively charged and dye is also negatively charged, so there is electrostatic repulsion. And vessel spacing, that is, there is no significant changes found in the vessel spacing also, and no significant change was found in the surface charge also. But in case of the organomonolite, in case of the CV, dye adsorption generally reduced due to the cationic nature of the organoclay, because CPC which is present on the surface, and that because of this the surface surface of the organoclay that become positively charged. So uptake of the dye was generally reduced. But in case of the indigo carmine, uptake of dye increase in case of the organomonolite because of the electrostatic repulsion again. So these are some possible interaction, and because my slides are not moving in case of the slide presentation mode, so I'm just trying. So this is generally interaction, because the crystal violet dye, this is the cationic in nature, and this nitrogen group generally interact with the oxygen group of the silicate. So this is in case of the crystal violet dye. And if I discuss about indigo carmine dye, then the sulfonic group of the indigo carmine dye generally interact with the nitrogen group of that CPC. So because of the electrostatic interaction, generally it become possible. So I hope now my slides are visible. Can I move again?
No, it's okay, madam. Please continue.
Okay.
And then be little faster, because
Yeah.
we are
Okay.
having 22
Okay.
slides.
Yeah. So by considering all the optimized condition which obtained during the batch extraction studies through the ion exchange method, these clay-based nanopigments can be prepared. So these clay-based nanopigments, these are the clay-based nanopigments. You can say this is crystal violet, this one upper one, and this is the indigo carmine, this which is of the blue color. Now there are different methods which are used for the dispersion of these pigments in the polymer matrix, and here I'm using the solvent casting method. So you can see here through the solvent casting method these polymer films which I obtained, and the polymer film which obtained in case of the organomonomonolite, they are more transparent and more homogeneously because of the more homogeneously dispersed of these nanopigments. But in case of the pristine clay minerals, the particles can be easily seen by the naked eyes, which is not possible in case of the organomonomonolite. Now these are the mechanical properties of these polymethyl methacrylate films, and which generally prepared by the dispersion of the nanopigments.
Dr. Neeraj,
So,
you are still on the 12th slide.
Okay.
And please make it fast because at 4,
Yeah.
another one is start their talk.
Yeah. So in case of the organoclay, it is found that the mechanical properties was found to be more as compared to the pristine clay minerals, because these organoclay, they are hydrophobic in nature, and because of their hydrophobic nature, they easily disperse in the polymer matrix, and because of this homogeneous disperse occur, and the mechanical strength was found to be more. So next is the color fastness study of the polymer film, and here I took two samples. One is the pure dye, and other one is the organoclay based nanopigments, and this is the del E, which is the color difference, you can say. So more the color, more the value of the del E, so we can say more color fastness will be found. Means less the value of del E, we can say key that polymer film will found to be more stable with the UV radiations. So these this color fastness study generally performed by using the xenon arc lamp, and the film was kept under the UV radiations, high level of the UV radiation for 100 hours at 62 degrees Celsius, and this is the result generally we obtained. And on these results we can say that the polymer film containing the organoclay organoclay based nanopigments, they are more UV stable, more colors show color stability as compared to the pure dye. So we can, this is the conclusion that, and we can say found that CV dye was found in the interlayer of the pristine empty, and it was found on the surface of the organ empty, whereas IC dye was on surface of the pristine and the organ empty, as confirmed from the XRD. Dye edge of pristine organ can be used as validated product, that is a nanopigment in the PMMA polymer matrix, and we can say that the organoclay based nanopigments, they easily dispersed homogeneously in polymer matrix. We generally provide transparent thin polymer and more beautifully colored than the pristine clay based nanopigments, and because of this the mechanical properties were generally enhanced as compared to the pure polymer film, or you can say pristine clay based polymer films. So thank you all.